Now let us see some operations on stacks. I have listed the operations like stack, push, pop, peek, empty, is empty, and size. What is this stack operation? As I told, stack operation is to create an empty stack. It is to just create an empty stack. So when you are using an array to represent a stack, creating an array, just declaring an array, an empty array, it allocates memory space. It allocates locations in the memory, so as to store any number of items of the fixed size if you are using stack. Or when we are using the linked list, we just have an empty linked list, just start dynamically allocating when we require to enter or insert new items. So stack operation is to create an empty stack with a given size. So allocating memory. The next operation push. Push is to insert an item. Inserting an item. Inserting a given item into the data structure, into the stack. Either by using an array or using a linked list format. Inserting an item. So this requires one parameter, the item to insert into the stack. Which item we should provide in the program, that will be inserted into the array. At the top only, no need to mention because the stack operation is only at the top we insert item. Right? So push, this operation modifies the data structure, modifies the array. For example, the array is modified when we add one more item, insert, correct? Pushing one item increases the number of items by one, total number of items. That is why the array gets modified. The data structure gets modified. The third operation is pop. It is called deleting or removing. Delete an item from top only. So this is also happening at the top, item at the top only. Deleting the item at the top, pop. This removes one item. This returns one item. The item deleted will be returned. So we can take this item for display. Right? So this returns. Here also the data structure gets modified. It changes because the number of items gets reduced by 1 when we delete one item. But it does not require any parameters naturally because pop is to delete items. We don't provide any item. We require item here only on the insertion operation. Next is peek. This returns the topmost item. It does not remove it, but it only returns. Correct? It is to return the top item from the linked list or array at any time from the stack. Which is the top item? To find out that, we can have this operation peek. Does not require any parameter, but returns the top item as the return value. Next, isEmpty. Usually, isEmpty is a check type of function operation which is used at any point of time to check whether the stack is empty or not. So accordingly, it returns a Boolean value. Returns a Boolean value, yes or no. Right? Yes means is empty. Yes means it is empty. Stack is empty. Right? The top item is not there so far. Of course, no item is present in the stack. In case it is not empty, maybe partially full, at least one item is there, or it may be completely full. In such case, it returns false. So, what is the purpose of this operation? To carry out any operation on a stack, the stack must be not empty, correct? It must have at least one item there. Either it is full or one item at least. Then only we can proceed with the further operation. So when first it is checked and if you find that the stack is empty, probably we do not have any operation to do on the stack. So that is why usually it is checked, used in the programs. Next, size. So this returns the size of the stack. Right? Size means total number of items. Total number of items on the stack at any time. Whenever you call, it returns the number of items present in the stack. So these are some most common operations on stack. Now let us see the algorithms for the two very important operations as I told, push and pop on stacks. What is push operation? We have seen now insertion of an item into a stack. The algorithm is very simple. Now let us say a stack using an array. To make it simple, a stack using an array. Suppose the stack is empty, right? Like this. Now top is usually taken as -1. You know, top is taken as -1 to begin with, because there is no item. So this status indicates that the stack is empty. Inserting a new item, push algorithm, push stack, right? Algorithm. We should have an item to push. Suppose we have a new element, item or element like 100. So far stack is empty. Where do we enter this? Where do we insert it? At the top only. But how much is top now? Top is not there. No item. Top is -1. So which is the expression indicating the insertion? Top is top plus 1. Now first increment the top. Top is pointing to the 0 index now. Top is top plus 1. Then you can assign this new item into this index. So assign 100 here. Correct? How do you assign? If the name of the array is A of 5, suppose 5 are the total number of items in the stack. Right. Declared size is 5. Top is top plus 1. -1 plus 1, how much? 0. So at the index 0, we are inserting the given item 100. Now the stack contains only one item. The top item, the same item 100. Correct? So top is this one now. Inserting one more item, suppose 200. Here only we should insert. Increment the top first. Top becomes top plus 1. Top is 0 now. Top plus 1, 1. Top becomes this one. So the insertion happens 200. So in the same way, you go on inserting by first incrementing the top, right, and then assigning the item to that position of an array. Now suppose after inserting all the items 300, 400 and 500, now let us see. As we have seen, now the stack is full. Can you insert one more item now into the stack? No, since the stack is full. So this has become the top item now. Top is n-1, it is 4. Top has become 4. Index is 4. Can you insert one more? No. Why? Because the stack is full. Why? Because the index n-1 we have seen. Why can't you insert one more? Because the stack is full since the index is 4. Correct? Now, how to write the algorithm? First we check in the algorithm whether the stack is full. Correct? Why? Because in case the stack is full, it is not possible to insert an item into the stack. That is why when we check first whether the stack is full, if yes, we exit from the algorithm. There is no point in continuation because stack is full. If not, if it is false, that means either the stack is empty or partially filled. In both the cases, we can insert items without any problem. So now let us write the simple algorithm. Step 1. Now we shall check, like if top is equal to n-1, then print stack is full. So as I told, it can be either n, number of items. What is n? N is the total number of items. Maximum, right? Maximum number. It can also be taken as max sometimes. Maybe in the textbook it is taken as max. indicating the total number of items which can be inserted into the stack. Maximum number of items, max or n at the maximum, not more than that. Fixed size. Stack is full. And if so, if the stack is full, you must exit. Correct? There is no point in continuing. You write exit here, and then end if. Else means, as I told, the stack is either empty or partially filled. In both the cases, you can increment the top, right, and then assign. So, if not, go to step 2. It is top is equal to top plus 1. Step 3, stack of top is equal to item. Look at this statement. What is stack? I have taken the name of the array like stack. Right? Stack of n. I have taken the name of the array itself as the stack. You can also take like A. Usually we take the name of the array like A. The stack is the name of the array which represents the stack here. That is why stack is. Stack of top is equal to item. We know the new item has to be assigned to the top position. It is the index of the array. Index. Right? So this algorithm is usually written with respect to the array notations. The top is -1 initially. Right? So top is taken as -1, and then it indicates empty. Top is n-1, indicating the top is full. Stack name of the array, right? Assigning the item to the top position of the array in case it is not full. Correct? Incrementing the top, very important. Assign the item to be inserted to the position at the top index. That's all. Right? Step 4 end or return. So this is a very simple 3-step algorithm, right? If top is n-1, then indicating it is full, printed. Stack is full. If that is the case, you can exit because you cannot insert. If not, top increment the top, and at that position assign the new item to be inserted. So end of the algorithm. And in the same way, we can write the deletion algorithm also. Now let us say, hope you have understood this push operation. Now let us see pop operation. What is pop? Pop is deleting one item, removing an item from the top, from the stack. So same thing, suppose this is the array of fixed size 0, 1, 2, 3, 4. Top is -1, indicating that it is empty. When we are deleting one item from the stack, what check we have to do? We have to ensure that the stack is not empty. Correct? When the stack is empty, can you delete one item from the stack? No, because stack does not contain any items. Correct? So first we have to check here whether the stack is empty. In the same way we have checked full in the case of insertion. Here we have to check whether the stack is empty. In that case you cannot insert, you have to exit. If not, it is either completely full or partially filled. In both the cases, you can definitely delete the items by decrementing the top. Correct? So here, first in the deletion algorithm, check whether this is empty. In that case, how to check empty? Top should be -1 when it is empty. So either top is -1 or null can also be taken, because using pointers we take null to indicate the top as the empty, right? Null to indicate empty linked list. In the case of stack representation using linked list. So normally we take -1 to denote empty stack. Algorithm step 1. If top is equal to -1, right? Or null also you can write, top is equal to -1. Then print stack is empty, exit and end if not means it contains at least one item, in which case you can definitely delete that. So when you delete the item, you better store it in a variable, as we have seen in deleting an item from the array, right? Better you store it in a separate variable so that you can display it to show which is the deleted item. So in case you have to display it, store that in a different variable. Like step 2, item is equal to stack of top. Remember, this is the array notation because top is the index here, stack is the name of the array. So that item is first stored in a variable like item so that you can display it. So next, step 3, top is equal to top minus 1. That's all, correct? Here you can display, print, or separate step also you can write, no problem. Print deleted item is equal to item, this item. You can print it. So next step 4. That's all. So decrementing the top so that the item at the top becomes out of reference and the previous to that becomes the topmost item available on the stack. So deletion is a very simple 3-step process. If top is equal to -1, then it indicates stack is empty, and if so, exit, not possible to delete. If not, means stack contains at least one or more items, it may be full also, you can definitely delete. So deletion, store the item to be deleted at the top into a variable like item so that you can display later the deleted item. Next step, decrement the top. Top becomes 1 less. So number of items becomes 1 less. So thus we have seen the stack push and stack pop algorithms. So these are very important algorithms, can be together asked for 5 marks or individually can be asked for 3 marks each. Thank you. And also the applications of stacks we have seen. Applications, right? Applications. In the previous class, I think I mentioned this, but anyway, so these are used for various applications like backtracking, right? Then conversion of decimal to binary, like backtracking. For example, the maze game, right? Where we have to remember the previous decision points, right? To come back to the previous point where you have diverted in case you got through the wrong route, right? So it is a backtracking. Wherever there is a backtracking concept of games, that will be done using stacks. So next is conversion of decimal to binary. Decimal to binary programs, logic. Conversion of decimal number into binary. Right? So there also stacks are being used. And also reversing strings. Reversal of string. How to reverse a string? Take each character from the string and push into a stack, empty stack. And later pop items from the stack. So pushing each and every character into the stack and popping reverses the order. Naturally the string gets reversed. Push and pop. These are the two operations you have to do in sequence to reverse a given string. The string, each character push into the stack, then pop the characters. The string gets reversed. So next is in the case of undo operations in various text processors and even in browsers. Undo operations. And in computers, in runtime memory management, and in the compiler language processing programs, inside the compiler to process various statements of the program, language processing. In dealing with the function parameters in programs, wherever we have functions in programs, to manipulate the arguments in functions. So they are pushed into the stack and accordingly they are accessed later whenever they are required. So in various features of the programming languages, compilers internally, the stacks are extensively used. And some other applications like Tower of Hanoi. So it's a classical problem. It's a game, right, where we are having 3 spindles like this, and on each rod we place discs, right, of varying size, small. So if suppose you have 3 rods and 3 stands, I think, and 3 discs, where you can just imagine the CD or DVD put into the DVD boxes, cabinets, where there is a central rod, right? So, but the condition here is you can place only a small sized disc over the top of a big one. You cannot place a bigger disc on the top of a smaller one. So the problem is, suppose the 3 discs, 1, 2 and 3. So this is the stand, right? The stand. So this one you can move here. So movement of one disc here, suppose this disc here. But the larger you cannot place over the bigger one, smaller one. So that is the restriction. And only one disc you can move at a time. So having these 2 restrictions, how do you transfer the entire collection of discs, maybe 3 discs, into another stand? So that is a problem. So here, so this one, and this second may be here. So here is one bigger one. You can place this one over here. So at any time you cannot place a bigger sized disc over the top of the smaller one. No, only small on top of the bigger, and moving only one disc at a time. So these are the restrictions. So this is the Tower of Hanoi problem. To solve this also, to write a program, you can search this one in Google. The programs are there for this. Depending on how many stands we have, how many discs we have, it becomes so complex. Right? So try this if you are interested, using 3 rods and 3 discs. Right? So this is Tower of Hanoi. And also in some other applications like the shares, right? Stacked trends, to find out the trends in stacks. Then railroad adjustment, reversal, right? In the railway station, when train is standing there and it has to move in the same backward direction. So in the railroads, this is being used. There are so many applications of stacks in day-to-day life also. So these are some applications you can mention. This can be asked for either 3 or 2 marks. So at least 4 or 5, if you remember, we can write the answer for applications of stacks also. And one more thing, in conversion of postfix, right? Conversion of expressions to infix to postfix. The arithmetic expressions in a language can be represented in 3 formats: infix, prefix and postfix. So in the next section I may explain that. Conversions of expressions from infix to postfix is done using the stacks. Why you have to convert it? Because the compiler finds it easy to evaluate postfix expressions, right? So whatever the expressions, arithmetic expressions we provide using various operators, how to evaluate those expressions? The evaluation is done using conversion first into the postfix format. So because postfix conversion is supposed to be very easy for the compiler, so convert first infix into postfix, then evaluation of postfix. So for these operations also, stacks are extensively being used in language processors. So these are some details regarding stacks. Thank you.